Discussion time, then Dan is going to lead our discussion.
Okay, I'm just setting this up. Well, very good. So we have 11 talks that we've had in this session, and a wide range. But before we get into the discussion, I would like to thank and acknowledge Professor Hashimoto for putting this together, because we're winding up now, and the younger people in the audience won't appreciate this fully, but the idea to actually to go ahead and take a chance on arranging a meeting and organizing a meeting and starting to get the word out there, it's not a trivial task. And I think it's, as somebody who worked with young students, undergraduate students for most of my career, I know what an impact it has to have a meeting like this held at your host institution, and so many people have benefited from that. So I'd like to give him a round of thanks. So let's go ahead and let's do this in two parts. We've got time, maybe we'll take 15 or 20 minutes to field questions from these 11 talks that we've heard over all of today. And then I've thrown up a few questions that came to my mind about some of the things that intrigue me the most about these topics. But really, you know, this is a group effort, and the people online should also be participating. And so why don't we just open this up for discussion about any of the talks that we've heard today. Let's start there. So somebody monitoring the online to see if we've got any questions from, no one yet? Okay, very good. Please, go ahead.
Dylan Joe. Okay. For
Dylan Zhao.
Sorry.
Yeah.
Dylan Joe. For the wave influenced by gravity, and we influence the origin wave. And how do we know that is correct? What method we can use, and how present correct? Yeah.
Well, I think so. One thing that I was talking about is that, you know, it's really one of the reasons that FRBs are so interesting is that they're these coherent, right? So the radiation is coherent. Oh yeah. So the radiation is coherent. So this means that you have these phase correlations between the lensed images, right? So it's true that if the FRB was lensed and you didn't have this coherent effect, maybe you wouldn't know that it's due to lensing, because it could be just that the FRB is doing some strange thing. You know, we've seen throughout this conference that there's these interesting morphologies of FRB bursts, right? They have these sort of strange structures. So it's really by using the coherence of FRBs that you can potentially determine that this was these repeated bursts or echoes are due to lensing and not just some strange thing. So I hope that answers your question.
Thank you.
So again, thanks to everyone for what I think has been a very successful and lively meeting. I was just looking on the online. I as far as I could tell, only the people on site are still online, and I think that none of the online speakers are still online, unfortunately. So we can only discuss topics of people who are present. So amongst those, and I think that's true for every single one of them. I don't know, Paz, are you still online?
Yeah.
Good. Okay, excellent. So we do have someone here. Maybe, since in fact we had two talks between you, and I don't know whether you had a chance to hear Alvina's talk and Jennifer's talk. And perhaps if one of you three have comments on whether your two approaches are related, or are you discussing unrelated effects?
Yeah, so I can't comment because I haven't seen those talks. This was all happening during my nighttime over here.
In that case, it's up to Jennifer and Alvina to comment.
I'm still processing what has just said about the multi-path propagation, because the way Alvina and I approach it is really thinking polarized radioactive transfer, and it can be done for one ray, multiple rays, but then with sort of the depolarization lead by multi-path propagation. I guess my understanding is first what is leading to that multi-path propagation. Are we talking about inhomogeneity in the plasma lens, or are we talking about definitely turbulence? So in past presentation, my understanding from your sketch, it is from turbulent. Hello? Hello? Oh yes, sorry, it's just the microphone. So it's from turbulent cell, but at the same time, it could be inhomogeneity that causes that scattering. And then in that cases, that we kind of can understand depolarization kind of through that sense. And the way that you also just mentioned about the Faraday wedge that can cause circular depolarization, circular polarization. So that's another matter, because now we are looking at V, not just the linear polarization. So I guess we are kind of coming in a common ground, thinking about what thinking about what is giving rise to the polarization feature we see. But I must say the explanation to like depolarization or the circular polarization, that I need to think about that more carefully. If that answers Wei-Li's question as well, and if Alvina, you have anything to add?
Maybe just a slide down. So thank you, Paz, for a very interesting talk. I think if I understood correctly, you were looking at some temporal resolutions that might be causing the depolarization. But from my experience, my very limited experience, we've only been looking at depolarization spatially. So I think that's one little thing that we haven't really thought about, which I thought was really interesting in your talk when you look at how circular polarization could arise from this temporal effects, if I understood correctly, but please correct me if I'm wrong. Yeah, thank you.
Comment briefly, thanks Alvina. So the effects of depolarization essentially happen in our picture because you have a finite temporal resolution of your detector and a finite spectral resolution. And both of these effects, if you have fluctuations of the waves on scales that are smaller than these resolutions, can lead to depolarization eventually. And both of these effects could be important actually, the spectral depolarization and the temporal depolarization. Regarding the question about whether we need turbulence, we don't necessarily need turbulence. It's enough for the plasma to be inhomogeneous. Now, all that being said, it's not always the case that you will have depolarization. So certain conditions have to be satisfied in order to get these depolarization effects. Like I showed, the typical frequencies that you can calculate, you have to be below those frequencies for those effects to take place. Otherwise, for example, if you're in a weak scattering regime, there's no depolarization due to this effect.
Was that helpful, Albina?
Yeah.
Good.
Thank you.
Anyone else have a comment or a question connected with polarization and the coherence of the FRB radiation and information we can extract from the fundamentally coherent nature of the radiation? Yes, please, Jennifer.
I have a question actually for Whaley and Dylan, because Dylan's talk about decoherence, whereas Whaley's talk really talk about how we can utilize the coherence of FRB source, particularly as it's extragalactic. So what can we gain when we look at the decoherence? Are we understanding more about plasma lens and how decoherent FRB can be?
Well, one thing that I didn't really talk about this in my talk, but sort of an important point that should be made is that I use the word decoherence, right? But there is no sense in which the radiation from the FRB ever becomes truly decoherent, right? Because the coherent emission mechanism, it's always, the radiation is always coherent. The subtlety is that when you have this scattering, right, this sort of limits your ability to do these coherent search methods. If you have a gravitational lens and you have an echo, right? So the scattering may cause the phases to be uncorrelated, which is sort of is kind of like decoherence in the sense that you lose that ability to use the coherence, right? But you still have, but ultimately the radiation is still coherent, and which is why you can use these techniques from pulsar scintillation, borrow these sorts of techniques and apply that to FRBs.
Thank you.
Is that a good answer? Whaley, anything to add to that?
Yes, thank you. And I think that's maybe, I think Path touched upon this topic very briefly in his talk as well, about that if you have two scattering screens, two lensing screens, that they become, that it gets more difficult to figure out what they're doing individually. Again, if you think of it as a scintillation pattern, then the modulation index remains 1. So it's not as if the interference goes away, because you still get 100% interference of your light, and all your observables stay unchanged.
Thank you.
Yeah, go ahead.
I was going to drift off topic if that's...
Okay, which direction were you thinking of going? Because I was wondering about the telescopes that we're building, because we've got at least 3 telescopes listed up there. We've got the DSA, and Vikram also told us about another project that they've got going, and then we've got BURST, of course, near and dear to the hearts of many here, and then there's FlimFlam. We heard a little bit about FlimFlam and what's going on in Australia with that. So I guess my general question is, are enough different directions being covered? Are there if we just could start thinking from the ground up, is there anything that's missing in the way that people are approaching the problem? Is there anything that sort of a dream telescope that could be built that's kind of different from what people are thinking about? And maybe the answer is no. I mean, there seems to be a lot of variety out there in what people are doing.
So I cannot say anything about what kind of radio telescopes we need. You're all experts in this field. want to briefly mention that for flim-flam and flim-flam-like surveys, we just want big telescopes with big field of use and a lot of observational time. So that's the hope. But so probably our pilot data release and the full sample data release will actually convince committees at the big telescope to give us time so we can probe deeper universe.
So just to follow up on that, so we're in an era where these big synoptic telescope projects are going to be coming online. You know, the Rubin LSST project is going to be a very major enterprise, and so is it going to detect you know, optical flashes from FRBs?
So maybe I'm not the appropriate person to answer, but I think it really highly depends on the FRB model, I mean the simultaneous counterpart model. If I remember, some model actually do predict the detectable brightness in optical flash, but it also, I think, that really depends on the time scale of optical counterpart. If it's very short, using the current standard optical telescope, it's hard to detect because their time scale is much longer. They don't get the really high SNR. Therefore, as Nino-san presented the first day, if you can really use a fast camera, say with very short time scale camera, then you may be able to detect a very short time scale optical counterpart as well. So yeah, it really depends, I think.
Hi, just to follow up on Tex's comment, maybe there's scope to use atmospheric Cherenkov telescopes because these are detecting optical light and have time resolutions of nanosecond scale. So although they're designed to detect gamma rays, it's data that's being thrown out and potentially contains this kind of information we're looking for here.
Right.
I was just going to ask, move us to another topic, but if there want to
No,
go
that's
on.
fine.
And that's on the cosmology font, perhaps, which is, I would like to hear people's opinion on what I think are some major elephants in this business that people pretend is somebody else's problem. I'm going to start with something that some of us have thought a bit about. Is there's a phenomenon in our galaxy called extreme scattering events. The interstellar medium experts that I know, like Brian Gensler, he says, oh, this is clearly just some detail of dark matter explosions that will explain it all. And it's somebody else's problem. Whereas the cosmologists obviously think this is crazy, the dark matter cannot possibly be exploding, so it's clearly some interstellar medium problem. And it's a problem that a 4 orders of magnitude unexplainable mismatch of pressures that's going around. So this is just, everybody just pretends it didn't exist. We have lots of issues in our society that everybody pretends didn't exist, and this is a little bit like that, in a blind eye, because it's too embarrassing to actually have to think about it. And in a similar vein, I think in the FRB data and picture of what's going on in the grand scheme of things, I'm going to mention that some statements made that are hard to reconcile in my mind, and if other people have a way of reconciling it, I'd love to hear it. We heard this morning that our Milky Way halo has negligible DM, okay, at most 10, probably a lot less. And I feel that's not just a small detail. I mean, you could say, oh, maybe there's some pencil beam in our Milky Way that is empty of matter. I think that's an elephant, okay? You can't just make an empty column in our Milky Way that doesn't fill in instantly. Or you say our Milky Way is so special, every other halo has a lot of DM, just ours has none, it's just been a special place. But you have to say that, right? You can't just say, oh, I pretend this problem didn't exist. So I think everybody, so since you had thought about this, Would you say our Milky Way is just totally different, or they're wrong, the measurement is wrong? But you've got to have a position. You can't just pretend this didn't exist, right?
Well, I think that Milky Way shouldn't be in a special place in the universe, obviously, but you should bear in mind that those distributions that I showed for DM halos, they are estimated from tens of halos. So this is a cumulative quantity. So individually they contribute some less, some more than this 10 value of 10 estimated for the Milky Way, but just I think the number of halos that you intersect. But then I don't think also that we have enough statistics to say that all halos in the universe should contribute exactly the same value, or they contribute different values. But in any case, I don't think that the difference would be huge. It's not like one galactic halo contributes 0. Like if you place two of them together, it's not like one will contribute 0 and one 100.
I thought in your picture, the linear distribution is, because you have different impact parameters, and for external halos you can do that. In our own halo, we don't have a choice. We're in the middle, if you like it or not. In other words, I'm not sure that I didn't understand how your answer gets you out of this elephant. That our Milky Way has no gas, and all the other Milky Ways do have gas, at least if so. The question is, to observers in the middle, if you have a line of sight that passes right through another galaxy, is that still a distribution, or is that a number?
It should be a distribution, also because, again, because of the uncertainties in the halo mass.
A fixed mass. I give you exactly the 220 km per second rotation curve. Is the EM a number or not?
Sorry, perhaps I should point out there are also some discussion ongoing on Slack exactly regarding the value of the DM halo of the Milky Way. There are a few people debating your comment about somebody commenting that the Milky Way halo, DM halo has a value of 10. So there seems to be I'm not exactly sure I follow everything. There seems to be some disagreement on how precisely the issue is known. But so that's sorry. Let me share if I can. I'm sorry. Then we'll have to stop sharing first. That's what WebEx tells me.
I mean, that of course is a solution to just say that measurement is wrong, interpretation is wrong. I mean, that's obviously but it's fine to say that, right? It's fine to just say, oh, I don't believe that measurement.
All right, can you see? Yes, so there's a few discussions, there's some discussion going on Slack.
Let's see, the first one says, very much, this is from Clancy James to Ilya. Very much looking forward to these flim-flam results coming out. You showed one plot giving a distribution of DM halo, I believe. Is there some simple way to scale between models where you publish estimates for different hypotheses of the halo structure, etc.? Obviously, it would be great to beat cosmic variance by subtracting out these contributions, but it'd be great to account for different models of DM halos. By the way, where do the uncertainties come from in DM halo? This is due to localization uncertainty in the FRB. So a lot of questions for you, Ilya. You can field as many.
No, but I answered this question, so I think
okay.
we're referring to the second question by Clancy, and
Yes,
the discussion that kind of we're having
Okay.
here right now. But so I'm not sure we actually know a lot about the actual, what is the true model of galactic halo. People assume different models, and they will give you different answers to of the estimate of the DM.
No, but it cannot violate physics. You can't just say the left half of the Milky Way has a lot of electrons, the other half is empty. That's not allowed by physics. So I'm not sure that that's allowed, right?
Well, sure, it is not allowed, but you're trying. I don't want to say that it's a one-way in the universe and that's a constant. It's like speed of light. I don't believe that. So I think there is definitely distribution, but I don't have an exact answer why. It's just something I believe based on some foreground galaxies that I looked at.
But I think this is all very interesting. And again, I'm always come from the very basics of the nature of questions. I always like to think, obviously the universe may be very complicated, everything is a distribution of a distribution, but Occam's razor seems to me would let us ask if there's a measurement. The zeroth order question is, well, let's assume everything else is the same. Is that allowed? At the first null hypothesis to be asked, because it's a well-defined question, it may be wrong and ruled out and then you make progress. But just to say from the beginning that everything is different, I don't know if that's a helpful starting point for data interpretation. That's that's my take on trying to understand data, understand what we should be measuring, understand how we should be looking at simulations or otherwise.
But why should we assume anything? I mean, we measure what we measure. So there is no assumption that it should be the same. Right?
Occam's razor, that's the simplest model, that's the one you start with. Doesn't mean it's right, it's more testable, right? So every time you allow for more things, there are more possible outcomes. So everything being the same is just has fewer parameters than everything being different, that's all I'm saying. No physics in there.
Sure, I mean, okay, so naive question, how do we estimate the DM of Milky Way halo? To what extent, for example?
From the Sun to some other galaxy, that's what those guys claim they've done, right?
Well, then to other galaxies, that involves DM IGM as well.
And exactly, they assume that there's no IGM, so what they did, you heard, right? They said they have a zero DM basically. That's what they're saying. So the sum of our halo DM plus the other side's halo DM, the sum of them is less than 10, that's what they're saying. I'm just saying that's what they're saying. You don't have to believe them, I'm just restating what they said.
Yeah, it's hard to believe that this is possible.
I mean, what's known on that question from just the standard pulsar result? I haven't followed it that closely. But you've got pulsars spread out fairly deep into the halo, but maybe not. Maybe they don't go out far enough. And then we go out into the LMC and the SMC. And so what would be a summary of what comes out of NE 2001?
Yeah, we did look at that a little bit in the Keating and Penn paper on why it's so uncertain, and as you say, pulsars. So I think the globular cluster pulsars are consistent with halo having no DM, but they're not that far, typically not that far away. LMC and SMC are actually 100 kiloparsecs away, so actually at the edge of our halo. But there the uncertainty comes of how much DMC LMC contributes. So that's why both are allowed from just pulsar data alone, and then the constraints come from things like X-ray backgrounds, which are more messy.
Also, one comment from Susan. About the current measurement on the Milky Way halo from recent papers. It's about in between 30 to 50 per cubic centimeter, and the others show 50 to 100, of course, maybe using the raw DM FRB from recent progress in observation. So I guess maybe there is no kind of very smart way to maybe limit Milky Way halo, but we need lots of sample of FRB with dispersion measure, hopefully around below 50 or of course below 100. This kind of sample will be collected by maybe future chime and also burst. We are focusing on very nearby objects, and we get more and more. So maybe this kind of statistical argument only can help constrain Milky Way contribution. Right? So this could be the good addition to parser, of course.
It's a very good point, Shitaro. Well, what would the organizers like us to do at this point? I think there's probably a transition that takes place, and I think Wei Li is up next for some concluding remarks. Okay, very good. Well, I'd like to thank people for the discussion. Very interesting.